Hello class and welcome to Module 3, the Windows operating system. This module will be a little longer than the last two. As you probably know, the Windows operating system is massive. There's a huge amount of Windows PCs, servers, and systems out there. So the Windows operating system is only, 200,000 files on base. But then when you actually add updates or additional functionality, it starts going in the millions. So there really isn't a single person anymore who's a subject matter expert on the Windows operating system without having some subset specialization, because it has become huge. It's incredibly modular, which is part of why it's very popular, and it's one of the biggest, if not the biggest, in at least consumer operating systems, with Linux being for more of the commercialized system. So Windows is super important. We're going to take this lecture to go ahead and jump into the Windows operating system, some of the key features and some of the things you need to know about, especially when it comes to cybersecurity, because we have lots and lots of Windows systems. We need to defend these Windows systems. So let's jump into it. I'll probably break this video up into one or two parts because this will be a bit of a longer lecture. So a little more digestible for you. All right, so our objectives, you can find them at the top of the module on Canvas, but we'll just go over them here. So the history of Windows, it's long and storied, you'll see in a minute, but it has continued to be pretty much the monolith it has since its inception. It really revolutionized personal computing. Some of the operations and architecture, how Windows, the file systems work, how the Windows servers work, etc. We'll go into stuff we are more interested in, which is configuration, so hardening, which means to make something more secure. And of course, how to monitor Windows, where we'll have our, our SIEM system, grabbing all those great Windows logs and sending those up to our SOAR. And then Windows security, they offer their own security stuff. Then this will dive a little more into what we can do to make Windows more secure. They're pretty on top of security, but as I mentioned, couple 100,000 for base, and then a couple million. There's always going to be some sort of exploit that people find. So it's always a race against time. If you have a personal Windows machine, do not ignore the updates. They are important. They are very quick about turning around exploits. So don't leave your Windows device open. Always have either auto update on, or just make sure you're at least vigilant in changing your updates. So we'll start with 3.1, Windows history. So the disk operating system, or DOS, is an operating system that the computer uses to enable data storage devices to read and write files. So this is pretty much how we actually check our hard drives. This is where the Windows system will sit on one of our hard drives, normally on the C drive. That is the default. So DOS will provide a file system which organizes the files in a specific way. It has its own order. The Windows file system has its own hierarchy and order. If you have a Mac, they have their own order. Flash drives have their own order. So whenever you have any two systems with different file system orders, you have to see if they're compatible, or often drives and systems need to get formatted to make whatever the operating system, so the DOS in this example, happy so that it's actually able to read your files. So with MS-DOS, the computer had a basic working knowledge of accessing the disk drive, loading the operating system files directly from the disk as part of the boot process. So that's how we pretty much started our Windows back when Windows was first starting. So earlier versions, we finally got a GUI, which is the graphical user interface. It's the actual desktop you see, with the Windows button on the side and all your icons and stuff. That MS-DOS launched, and that you actually had a GUI now. So it wasn't a terminal system. It was a graphical system that really is where the consumer interest came, because a lot of people don't have trouble operating even Linux when it's the desktop version or the GUI version. But when you're just doing a terminal, sometimes it's hard to track where you are in the file system and where you put what, etc. Just visual is easier for the most part. Some people might say they're more terminal people, but I personally prefer a GUI. I'm a consumer. I have a personal PC at home, right? So I like my Windows GUI. So in newer versions, it's built on NT. The operating system itself is in direct control of the computer and its hardware. And then today, we have a bit of a mix between our MS-DOS command line is pretty much built in now, so we can access this through the command line in the GUI, so you don't really need to launch just a DOS version anymore. You can just open up a command line and fire off your DOS commands if you want. So you can open it send CMD and then pressing enter, this will give you pretty much all of your, this will open your terminal. So you can, again, play with your terminal. We'll be doing this in some labs, more on Linux, but regardless, some of the labs for this section also has you exploring the terminal. I'm sure many of you have opened a terminal on your Windows machine, right? So here are some commands. Again, they're DOS commands, just commands at this point. You don't really need to say DOS commands anymore. The real difference will come down to either your command line or your PowerShell, but we'll talk about that later. So here, if you're familiar with Linux, a lot of the things are similar, but there are a lot of differences too. So it's a little annoying when you're trying to memorize all your Linux shortcuts and then you switch over to your command line terminal on Windows. You're like, oh shoot, that's not how you change the directory. That's not how you type a command somewhere. So anyway, pretty easy common words, copy, make dir, so obviously make directory. So you can kind of figure out the commands through memory just of the real words, but also if you're trying to read command line, for the most part, it's pretty easy to kind of like del, meaning delete, right? So a lot of common words or word parts. It's not just like command 76 and obviously you have to remember exactly what that does, and that copies a directory over to your 6th folder or whatever, right? So in Windows versions, 1993, there are more than 20. I bet a lot of you have gone through some of these Windows versions, kind of grew up with us at this point. If you were from the 90s, if you're older, then you've probably saw it from the beginning. And if you're younger, then you still probably have seen multiple versions of Windows, because it does change relatively often, every 4 or 5 years or so, are really the big changes, but even version of versions do have significant functionality changes, especially with a lot of the Linux integration now. It's very cool. So they're normally built specifically for Workstation, Professional Server, Advanced Server, and Data Center Server. So as I mentioned, it's pretty modular. You have that base Windows operating system, but then you load all the stuff that you need on top of it. So if it's a personal computer, you want all the goodies for running applications. If it's a server, you might not want all the goodies for running certain applications. You might just want to be able to install packages that have their own dependencies, rather than having to rely on more universal GAC or global assembly cache. It's not too important to go into that right now, but the 64-bit operating system was entirely new. It's pretty much the standard now with 64-bit address space. That's where it gets the 64-bit operating system name. So computers and operating systems are backwards compatible. Again, you can use a 32-bit address space because we have more space, not less. But 64, you can't stick more bits in your address space because you only have 32 for 32-bit hardware. So with each release of Windows, it has become more refined by incorporating more features. I only half agree with that. I think Windows has become incredibly bloated, and you'll see in terms of security, there are so many places and holes to plug now with Windows. All the base stuff has been refined exceptionally well because it's existed for 20 years, but all of these new additions, especially a lot of server functionality, all these new features, in my workplace, at least my personal experience, find that they break more than they fix, and then they fix what they broke by breaking more things. So I have a little bit of a vendetta against Windows. The work I work on is actually put on a Windows machine and not a Linux. So we always have to play, what does Windows break this time with the updates? Because we need to be up to date because we care about security, and it breaks all of our actual functionality. So anyway, Windows is good. It is a good operating system, but we are also pretty much limited to no other competitors besides Mac, which is a very exclusive ecosystem. So I do think Windows has definitely sat on their laurels and have bloated their operating system, but there are a lot of good features that they come out with too. So just a little jaded from every time an update breaks my work. But I do think Windows is still probably the best consumer operating system. I don't think Mac is quite there yet. So anyway, I grew up on Windows 7 pretty much. I didn't really see any other Windows. A little bit of Vista, I guess, but pretty much Windows 7 for me. Windows 7 was my favorite, but probably because I grew up on it. Windows 8 was notoriously disliked by people and had one of its the shortest lifespans of Windows operating systems. Windows 7 lasts forever. which is why they immediately went into 8.1, because Windows 8 was so universally disliked by consumers and even professionals, including myself. 8.1 did not fix a lot of what the problems were, but they at least fixed some of the things, like our right click being able to copy paste. I don't know why they think taking away general functionality is a good idea, but anyway. And then Windows 10 has come along and has already departed us. Let's see if this, nope, it doesn't list. So we're already at Windows 11. Windows 10 has actually end-of-lifed. They're no longer doing security updates. You probably already got spammed by Windows saying, hey, buy a new computer. Unfortunately, you need certain chip architecture. You need certain motherboards to actually run the chips that run the newer operating system. They didn't really, in my opinion, do a very good job considering older hardware for their Windows 11. That's what I'm talking about, that bloat. It really is a demanding operating system, so it needs the newest, or at least newer architectures. Windows 10 is still fine, but the lack of security updates is going to start being felt when people find, security issues and exploits. If you are still on Windows 10, I'm not saying you need to rush to 11. It's still relatively secure, but just be aware that, yeah, they've probably already, spammed you a million times of, hey, we're no longer updating this for security. So good to know. At my workplace, we cannot run Windows 10 anymore because of this reason. It's not a like, oh, we'll slowly sunset it. It's just hard. We cannot run this anymore. So we've been upgrading to Windows 11, and that has brought yet again a myriad of problems with all their new features, right? So Windows has a GUI, which, as I mentioned, here's your desktop, your great Windows logo. Did you know this was a real picture? This isn't actually like a graphic, like a computer-generated graphic. This is a photo, which is actually quite impressive. I didn't know that when I watched the filming of how they actually made this logo. It is a cool logo. Sorry, a little off topic there, but... So you have your start menu, your search, your icons, these quick launch. They're just tied to an application wherever the application is set. It's just a quick little shortcut. You click it, application launches. I'm not going to go into this too much. Generally, I assume most of you have used a Windows system or are currently using one, so you know where the recycling bin is. So yeah, I'm going to keep just going through this. Taskbar, that's just the name of the black bar at the bottom. Windows 11 likes to break the taskbar a lot and give you the black bar of death. Again, all those great features that keep somehow coming out in commercial releases when it's commonly a problem. But anyway, right-clicking an icon will bring additional functions. This is the context menu. Again, we had this nice context menu. If you're on Windows 11, you'll realize they took away most of our context menu because reasons. I don't know. They made it look newer, I guess, but they took away a lot of these. Maybe because they're worried of the too many options for people. Maybe that was a complaint. I don't know where they do this market research. It's insanely infuriating, and I always just press more options every single time on 11. It literally has doubled the amount of clicks I have now. So there is a Windows 11 fix that puts you back to 10, but I'm not allowed to run that on government systems, but I have it on my personal computer for 11. So anyway, operating system vulnerabilities is what we really care about, right? It contains millions of line of code. This is like more like multi-millions because we have millions of files, let alone millions of code in each of those files. There is not a single SME in Windows who could tell you every file at this point. There used to be people who knew all 200,000, right, of the base system. Now it is like you have subject matter experts in chunks of Windows operating system. It is massive. So do not expect, this is a longer lecture because there's so much to talk about for Windows. Do not expect to walk into a security situation and they go, hey, what is this Windows setting that does this? You're going to have to look it up just like everyone else because just about nobody has the Windows operating system memorized. If there is someone out there who knows the 2 to 3 million files by heart and where everything is, then I take it back. I don't think there is, but I'd love to hire them if they do exist because they have a fantastic memory. So regardless, more lines of code means bigger attack surface, more vectors for attack, more places that there could be a vulnerability. As I mentioned, they love to give us new features, and these features always have new vulnerabilities. So be aware of that. New does not mean better. New often means more problems. So the following table, some common OS security recommendations, have malware. So I personally don't find that malware protection is particularly important anymore. Windows Defender does a very good job protecting your file systems. As someone in the security field, I don't really need, whatever the, Kaspersky or Norton to tell me not to download a file from a very strange website, right? And Windows Defender already pops it and says, hey, this is a problem. And it probably is a little too aggressive sometimes, but it always warns you. It always gives you the signature if it has one. We'll talk about that a little later in the future, but pretty much most of these major companies can sign their programs. And if it's signed by the company, it's probably fine to run because it's made by the company. And that checks against to make sure that there wasn't any changes in the program. That's how it validates it. So do not turn off Windows Defender. It can be annoying and it can cause problems. What you should do is whitelist if you have an application that's being blocked by Windows Defender and you know this application is good. Whitelist it. Don't turn off your entire Windows Defender because it is quite effective. It's a little too effective, but it's rather that it has, these false positives, which means it finds something that it believes to be bad, but it is not, than a false negative, because you will not know that it is a problem because it doesn't pop up. It is a false negative, and it should be a positive, but it's not. So false negatives are always much more dangerous. So that's why I assume I'll give the designers a benefit of the doubt that they're overly aggressive because false positives are easily just a yes on the UAC, which is the user access control, the thing that pops up, rather than, oh, whoops, you just installed malware, there goes your computer, it's bricked, right? So unknown or unmanaged services, this is incredibly hard to follow because, again, there are 1.5 million services. Here, let me go and pull up my services real quick. Right. So this is my computer. I'm not running a lot. I'm running pretty much standard services here. As you can see, there are a lot. And this is why it is helpful to keep Windows Defender on, because it does look for these rogue services. These are things that are running in the background. They're applications that are pretty much going in the background. That's what a service generally is. So you can see which ones are running. You can see which ones are not, right? But the point being is there's a lot, and being able to find, the one bad service that's running is pretty difficult. But most of these services, so we'll just click on the Windows module installer, right? We hit properties, and you can immediately see here where it is, what it does. Generally, the malware doesn't have descriptions, or they'll say like description placeholder or whatever. You can see that it says trusted installer, which is a good trust, right? And it shows what it's displayed as. You can stop it, start it. You can change how it starts. So you can either have it launch, start at the beginning, like along with the operating system, or afterwards, which means after you've logged in. You can change it to log in and start the service immediately. So there's a lot of levers and valves you can turn to customize Windows. So one of those things you can do is play around here in the services menu. Just go and close that. Continue with the lecture here. Encryption. Windows has BitLocker already built in. You can encrypt your hard drives and then save keys. I do recommend that if you are getting a new computer and you have a hard drive that's not going to the new home, do not throw it away. Do not take e-waste. People will take it, put it in their computers, and try to steal your data. The best thing to do is physically destroy it. So you got to drill through it, got a hammer, smash it. But before then, you could even be extra safe, encrypt it, throw away the key, so pretty much brick the entire hard drive, and then drill it. So just a personal opinion what you should do with hard drives. But anyway, when you're done with them, security policy. A good security policy must be configured and followed. Windows, let me go ahead and open group policy for you to show you what it looks like. Just a quick look at here's just a screenshot of it. So you can go ahead and change your computer, which is your local computer's configuration, or you can change just your user. There's a lot of different folders, and then all of these folders have different settings that you can go ahead and maneuver. This isn't something you're going to find on a home system because you don't typically need to do editing of policies because you are the only users generally on your computer. But it is good to be familiar with this, how to move around it, where things are set, what's in the templates, what's in the Windows settings, what's in software settings, etc. Windows Components is going to be one of the ones that has a lot of things that you're going to end up editing because those are all the Windows valves that you can change. So being familiar with this will be important. because a lot of the stuff we do is setting these policies, these security policies, and making sure that we harden our system before we ship it out to, whoever we're giving it to. So 1 second, back on the lecture here. So firewall, we've already talked about Windows Defender. The Windows firewall is built in, the firewall is built into Windows Defender. It's important to review its setting periodically. I do agree. Sometimes, again, it can be overly aggressive in blocking things that you need it to not. And sometimes it kind of just doesn't keep up with, say, a new report you open, etc. I'm not sure how much you guys are doing that and messing with your firewalls. If you are, make sure you're very informed and not opening vulnerabilities into your home systems, right? So share permissions, again, it's not particularly important if you are the only person on your computer, but these are normally assigned to users, and then the users have access to certain folders on the desktop. If you're in the business admin, you can only open business admin folder. If you log in as someone in the IT, maybe you have full access because you're an IT guy, so you need to find all of them. Weak or no password. Again, if you have a home computer and it doesn't move and it's a desktop, you might not always need a password on your computer, because if someone's broken into your house, well, if the first thing they do is log on your computer, then that's a interesting choice. But if you have a Windows account, if you log on to other computers, if it's a network or shared computer in any way, make sure your password is secure and not easy to remember. Obviously, the admin account needs to be locked up. And then logging in as admin, most of our standard users already admined, right? So you just right-click Run as admin, but you can separate this account so that it can only be used for administrative purposes, and normal users don't have admin permissions, right? All right, so 3.2. Let's go through 3.2, and then I'll do a little break and do a different video for the rest of it. So the hardware abstraction layer, so your HAL, is software that handles all the communication between the hardware and the kernel. So all of the Windows API, all of the information gathering Windows does, goes ahead and talks to your applications that are put on top. Those applications then share data to the API, and the API goes and heads and does its calls to your operating system kernel, which is pretty much the root of the Windows operating system. It can check for drivers if there are certain drivers for device that your application is using. And then you go all the way down to the abstraction layer, which is kind of your in-between of the physical median of hardware and the software side of the operating system. So this is kind of where we're talking about right here. The core needs to be able to talk to the physical. The core needs to be able to delineate timings and usages of, say, your CPU or your core processing. So the kernel handles all the input requests from up here generally, and then funnels them down to the hardware abstraction layer, which then hands it out to wherever you have your hardware linked, right? So the two different modes in which CPU operates has Windows installed are the user mode and the kernel mode. User mode is run on top, and the operating system code runs in kernel mode. So this is like the actual behind the scenes, not the stuff you're really seeing. This is what's populating what you're seeing. All the code that runs in kernel mode uses the same address space. So again, we talked about that 64-bit address space. Everything that's in here is in those 64 bits address space. And then when user mode code runs, it is granted its own restricted address space. So it has pretty much the first address space, 0, is where all your kernel processes run, and they hang out in there. Everything else is given pretty much a lease on an address space. All of the applications will run whatever data it needs in that, and then that address space will get cleared out for the most part after the process is finished. So your file systems, this is kind of what I was talking about. If you have a hard drive, you plug it into your Mac and it says, well, I don't like this because it's in HFS plus, right? Or it's not in HFS plus, sorry, because Mac OS has their own way of organizing files. And then exFAT, this is a simple file system that's pretty much, you can kind of go in between a lot of different devices with this. So FAT32 being more common and has fewer restrictions, it's newer, and it has a larger way it handles file systems. And then obviously it's not supported by Windows. Windows is able to read it, so it's kind of treated as like a rogue file system. It can just generally grab files from it, but it doesn't actually organize them for you in the same way Windows does. I don't think Mac has the same compatibility. Maybe the new OS does, but I know older Macs just straight up will not allow you to use the um, Windows operating system. So file operating system. So NTFS is the Windows one. It's generally what is kind of like the go-to one. Linux also supports it, so a lot of times Linux systems will just be in this because it's easier to be able to move data and hard drives in between your Linux systems or maybe your Windows server. And then your extended file system is a very simplified file system, and it works very well on like servers or light, running hardware. Um, it is not supported by Windows, and again, Windows is able to actually read it if you download the correct software. It's not too hard, but generally, you're not really putting an extended file system into your Windows. You're going to have it set to NTFS. Your Linux is going to be supporting it, and then you can move it back to your Windows, right? So yeah, it says macOS can read a partition, so they can't write it, but you can if you have special drivers. I assume that's still up to date, but potentially the new macOS. I know they've been doing a lot with Linux, so they've maybe gotten the Linux support for NTFS and then kind of jerry-rigged it up into their file system. But anyway, so the Windows file systems formatting creates important structures on the disk for file storages, tables for recording the locations of files. So you have your boot sector. This is all of the sections that handle actually launching everything for the operating system. And it also has the master file table. The last 16 also has a copy. So pretty much if this explodes, you have a backup, which is nice. Your master file table, this table contains locations of all your files and directories, so pretty much everything on the partition, including file attributes such as security and information. System files, they're hidden and stored information about other volumes of file attributes, and then you have your file area all the way down to the main area of the partition where files and directories are stored. So that's where generally most of your hard drive is taken up, is the file area. So when formatting a partition, the previous data may be recoverable because not all data is completely removed. So this is important to understand that data, when you empty a hard drive, it just takes away the protections from those partitions and allows them to be written over. That's how a lot of criminals actually have gotten caught, and most of the cyber criminals are smart to this now, is they wiped their hard drive, they deleted everything, but somehow all the files were still recoverable. It's because those files aren't actually removed until they are overwritten, until something else writes in that directory space. Or there are now secure wipes, which will pretty much overwrite all of those directory spaces with just blank nothing, so that they do properly get removed. But just be aware, when something's deleted doesn't mean it's actually gone. It just has not been overwritten yet, right? So alternate data streams, they store files as a series of attributes, such as the file name or timestamp. So you can kind of see here that here's the alternate data here, here's the actual name of it, and then you can actually see, this is when it was accessed. So take a minute, you can go ahead and soak this in, but generally alternate data streams can be connected to the file, and then the file gets additional information with this alternate data, right? So the file system, a file with an ADS, is identified after the file name and a colon, for example, textfile.txt ADS. This file indicates ADS called ADS is associated with the file called text file. Just pretty much that file has an associated alternate data stream. That's generally what that means. So Windows boot process. So we have the initial. So you have two different modes: basic input-output system. So this is like your bare bone BIOS, and then you have the unified extensible firmware interface. This boots additional programs or EFI programs. So these are from either special partitions or maybe a side boot if you're doing multiple boots of an operating system on one single system. Generally, you're going to just be using BIOS, and it's just going to go through here, post, throw up the boot manager exe, and then eventually it loads all of your file systems, everything. Here's your hardware layer, that abstraction layer that's talking to all the pieces in your actual computer, and then sending this information up into the operating system, and then the kernel goes and launches logon, so you can actually get into your wonderful Windows operating system. So whether the firmware is BIOS or UEFI, a lot of them are actually dual supported. Most firmware is pretty much both, but generally you're launching with BIOS. After a valid Windows installation is located, it runs the exe in that installation area and to launch actual Windows. So it reads the boot configuration, the BCD. This often is where people will plant viruses, because a lot of security software only runs after the actual boot has initiated. So they'll hide things here in the database, or this can be corrupted. So sometimes it needs to be wiped and re-added or updated again. So out of hibernation, it goes into Win Resume. So you can see here, is it already hibernating? Have we already done this? It's just sitting here on the BCD waiting to wake up. If yes, we can just go ahead and launch pretty much straight into our logon. But if not, we have to use WinLoad to activate the kernel mode code signing to make sure that all the drivers digitally sign. This makes sure that someone didn't edit your drivers, someone didn't add some driver that blows up your computer. So this is the kernel level control is very important to always protect, so that makes sure that you aren't playing around with drivers you weren't supposed to. And then once they've been examined, make sure that they're all signed, by Bill Microsoft or whoever the company it is for this. It's Windows. It goes, launches the exe, runs the kernel exe, then starts the Windows kernel and sets up the help. So pretty much this is just the few steps that are going through and opening your Windows operating system. And again, this is all base level stuff. You can see Windows operating system is a massive behemoth and has a lot of different little moving parts that are very important to know, because each step of the way, technically, there's going to be an opportunity for an attack, and understanding each of these little pieces are how you can understand how to secure your operating systems and your systems. Again, you're going to have subject matter experts who are masters of BIOS and the boot order. That is like their whole thing. They know the BCD back and front. Once you get in the login screen, they hand it to someone else, right? So startup, 2 registry items are automatically start applications and services. So this is on your actual computer. So anything on the system. This is for the person who has logged in. Several aspects related to the logged in users are stored in this key. So this is generally what you'd be changing when you're using just for my user, but when you install for all users or whatever application, will go here to local machine. So if you want to say install Java or Python, etc., you're going to want to make sure you're installing local rather than just the current user. Otherwise, the other users on the machine won't be able to use it. So these types include run once, run service once, and user initiated. So I already kind of showed you that services menu. You can have it just run only the one time when you're clicking it, run the services only one time, or wait until it's actually initiated. So you can go ahead and change that into registry, but msconfig exe tool is a lot better. So it pretty much is just a GUI for your registry editor rather than actually trying to just change the registry key numbers, which I don't recommend touching unless you, again, know exactly what you're doing. So there are 5 tabs that contain the configuration settings, so you could just type in yourself and type system config, or advanced system settings, I think is what they call it now in 11. So normal startup, load everything. Diagnostic startup, it loads just the very basic Windows operating components and services, just pretty much what it takes to log on. This is a way that you can find what is breaking your computer or the malware, because it shouldn't be launching this malware. That's probably a user application. And then you can, again, do selective, which is like playing with startup or turning off startup, going all the way down to pretty much the factory installation, or you can load all system services. So it's not particularly selective with its startup, but gives you a little more tools to play with, I suppose, for troubleshooting. So any installed operating systems can be chosen here to start. You might have a disk that you have another operating system you want to install, or a flash drive. And you're reinstalling Windows for whatever reason, you can go and boot it through here, or you can boot it through the BIOS menu. Either way, or this is an easier way to safe boot something, so you can just go and click that and hit safe boot, apply OK. That way, your Windows operating system is always in safe boot. You don't have to keep spamming the key or whatever to enter into safe boot. So all the installed services are listed here. Again, I showed you the services menu, but it's also all listed here as well, so you can turn them off if you need to. Startup, this is the things that will pop up as soon as you log in. Again, whatever it might be annoying you, you can also use Taskman to see the startup applications and turn those off if you don't want to be spammed with 300 applications as soon as you log in, because every app likes to turn themselves on for startup. And then tools, many common operating system tools can be launched directly. We'll be touching some of these tools, but these are incredibly helpful. They're all on the Windows operating system, so before you even put in your own toolkit, if you're going to diagnose a system, a lot of these tools have what you need. System Event Viewer is very helpful to see why something crashed. You can go grab, the crash code, system properties, change the UAC, which are the pop-ups for your Windows Defender, security stuff, maintenance stuff. I mean, there are a ton of tools. They pretty much give you all their developer side tools here on base operating system, which makes Windows very easier for IT professionals to be able to go in there and check the events, or security professionals as well. So Windows shutdown is always best from proper shutdown. It's probably a good idea not to just pull the plug on your computer. I assume most of you just press the shutdown key or the button after pressing the Windows key, but it closes in an order where it's all the upper level stuff, all your user stuff, and then it flows down pretty much reverse of what we saw for the boot to cleanly close everything, prevent your partitions from getting corrupted or something not correctly closing and then causing problems the next time it tries to run or in some sort of fail state. So you can Control Alt Delete and turn off. You can just type shutdown, or you can again press the button. I don't recommend doing the pressing and holding your computer button because that's a forced shutdown. Only do that if you have to. So processes, threads, and services. This is our task manager. It's our best friend. Our applications are the things that we're actively interacting with. Background processes are where all of our services are living. So Windows application is made up of processes. The process is any program that is currently executing. So in the background, it is running and executing. On the apps, it's more of the actual front end that we're seeing that is also executing. So a thread is part of the process that can be executed. To configure Windows processes, search for Taskman. The processes tab of the Taskman is shown in the figure. I assume, again, a lot of you have used your Taskman if you have a Windows operating system. Taskman is a good tool to just get familiar with. If you have a program that has gone white and frozen, won't close. Often the best thing to do is you open Task Manager, so you can do Control Alt Delete. I'm not going to do it because it'll get rid of the lecture, but Control Alt Delete, open Task Manager, or you can type in the Windows search bar. You can go ahead and look and see which processes. As you see here, the CPU is at 3%, so it's running great. Memory is starting to be eaten up. I don't know why a calculator is using that much memory. I don't know what they're calculating, something massive, I guess. And then obviously most of the time, a lot of your RAM is getting eaten up here, or your memory is getting eaten up here by your whatever your favorite search engine is. So you can take a look here, go, why is my computer slow, right? That's often a question any of us who know things about technology get from our parents, our grandparents, our cousins, or best friend, whatever. First thing I do is I say, hey, send me a screenshot of Taskman, because if they have 3,000 services running and a billion apps running, maybe go to the startup menu and don't have those launched unless they're using them. Maybe their memory is being overtaxed through normal use. Well, hey, maybe you need to get some new RAM sticks, right? You can use the Taskman. It's very simple and it's good for common day use, but it's also good for security because you can take a look through all the background processes. Oops, sorry. And you can see, hey, I don't recognize that background process. That looks really fishy. You can right-click it, look into it. You can use Event Viewer to take a closer look at what's actually going on. So anyway, so some of the processes that Windows run are services. These are programs that run in the background. We already kind of talked about this. Services run long-running functionality, so things like being able to connect to a server, etc. To configure the services, certain services, as I already showed you, and been very carefully when manipulating settings of these services. Taskman, if you blow something up, for the most part, you just restart the computer. It's okay. If you actually start messing with service settings, you're going to probably break things you don't really understand. And they're not going to relaunch because they've been disabled. So I do recommend, again, only touching things in your group editor, the GP edit, or your services, or even advanced settings if you know what you're doing and you're doing it with purpose. Because you don't really want to brick your computer and have to, send me an email and go, hey, I blew up my computer because I was playing with the services. Can you fix it? And I'll be like, I don't know what you turned off. Right? So a lot of this stuff, when we're digging into processes and the services and we're really digging into the kernel of any kind of machine, always do things with purpose, especially if you're ever doing like testing on a system that you need to track your tests and like record everything you do, especially if it's being, say, submitted for evidence. It's very important to make sure that you are doing things with purpose, right? So here's memory allocation. I won't dive too much into this. Pretty much, we've already kind of talked about virtual address is not the physical location, but an entry in the page table. So pretty much where it's telling us the page address is tied to the virtual address. It's kind of like your home is given a marker on the street. So there's the physical, coordinates, your X and Y on the world, latitude, longitude. And then there's the virtual address, which is like your street and your numbers on your street, right? So it says, oh, hey, anything that's meant for this place, you can send it through here. And this is an easier way for the computer to route whatever processes it needs to. When user space process needs to access kernel, it has to make a process handle. And as the user space process is not allowed to directly access the kernel resources, it's going to need this kind of like routing address. It handles the access needed by the user space process without a direct connection to it. So you cannot touch your kernel with your applications. This is kind of what protects your kernel from getting corrupted by, say, malware or even applications that are running and not running correctly. Sometimes, again, they bad code or whatever it is. It has to go through this process of kind of like, hey, I want to go to this house. Doesn't tell you exactly where the house is, but you can send it to this address and it'll eventually get to that house, right? So here's just kind of showing you, this is another sysinternals. Sysinternals are a super powerful tool that you use all the time when troubleshooting Windows. This is just the part that shows you your memory and where your memory is going, so your RAM map. So memory allocation RAM map is used and shown in the figure, as you can see here. Sysinternal Suite can get downloaded from Microsoft. I wish we had more time in this class because I'd love to do a Sysinternal Suite tool lab. We're only going to touch a few tools, but Sysinternals is a great thing to download and play with. All the tools are incredibly powerful and useful, and pretty much kind of the first thing you break out when you're taking a Windows system and trying to configure and or troubleshoot it. Okay. So the Windows registry, this is where we store pretty much all of the settings for anything in the operating system. So our hardware, our applications, our users, our system settings, everything is in this massive one-place database called the registry. The registry has a few root folders. These root folders are called hives. You can see the major 5 ones here. It is stored in a hierarchy, so it is stored with your hives at the top and then breaking down into the folders, which have keys in them, and then these keys have subkeys that are pretty much where you start playing with the settings, whatever, the ones or the zeros. If it's on startup, it'll be a 1. If it's not, it'll be 0, or sometimes they have different settings and different ways they classify keys. There's, we'll jump into that a little more, but pretty much these values store data. The registry key can be 512 levels deep, so you can imagine 512 folders going all the way down. It is a massive database, and it is kind of our central place when we're trying to play with settings or application registration in general, right? So here are the 5 major ones. The ones you're going to be messing around with a lot is your current user, so that's changing the person for, like is an application running, and then you can tie keys to users, and then those keys can get stored in the registry, and then when that user logs in, it applies that key for whatever software you're using, right? And the other one is your local machine, so that is, I want to change something for the entire machine. Those are the kind of settings that you're going to actually mess with, like launch of the Windows operating system changes, default applications, some of the more maybe hardware connections that you have, like the keyboard is going to be there for all users. So that registry key is probably going to be placed in the local machine, right? But the current config will also have some of your hardware changes. So anyway, so continued, new hives cannot be created. You can't really mess with the hives, and you shouldn't. Those are pretty much the master levels. The roots, you're not going to be adding more roots. The tree is just going to have, it's just one place it starts. In this case, there's 5 places it starts. So you can go ahead and do regedit to see all your registry keys. Again, sometimes you have a bad key that's connected to, say, Word, and your Word says it's expired, but you can't get rid of the key. This is the place that they would put your registration key, your unlocking key. So sometimes you have to go into here, delete it, so that Windows go or Word goes, oh, it's a new installation. There's no key here. Give me a new key, and you give it to it, right? So yeah, minor changes to the registry can have massive or even catastrophic effects. You can brick your computer, and again, as I've mentioned, do things with purpose. So continued navigation is very similar. Yeah, it's a hierarchy of folders, top level hives, and then you can go down from there, right? So registry keys can contain either a subkey or a value. These different values keys contain are binaries, so these are your zeros, ones, and all your numbers. A word, so these can be like pretty much massive numbers or like a string of numbers. And then your SZ, where you have string values, so you can actually have your letters. So the registry also contains activity that user performs during day-to-day computer use, which includes the history of hardware devices, including all devices that have been connected. So you can go ahead and use this. So if we're thinking in a security mindset, we can see everything that X user has plugged in and unplugged. So we know there could be a malicious flash drive, or they're plugging in some sort of listing device or a keylogger on a physical media. We can see all of those changes included on the registry of that current user. Okay, finally, we're going to talk a lab. I'm going to go ahead and pull this up, and then after we talk about this lab, that'll be the end of the video, so give me a second to pull it up. All right, so here we are in the lab exploring process threads, handles, and Windows registries. So we're going to go ahead and jump in and mess with some of this stuff. So as I mentioned before, System Internals is a awesome suite and has a ton of tools, and it's pretty much the first thing I break out whenever I'm trying to dig into a Windows computer. So we're going to go ahead and download it. The link's here. If this link doesn't work, you could just type sysinternals, Windows sysinternals suite, and go ahead and download it. So again, this is why I kind of said you need a Windows computer for this class, because sysinternals doesn't support Mac. So if you do have a Mac and you have VirtualBox, you can always try to get a Windows evaluation version and then download sysinternals on there to complete the lab, whatever you got to do, right? So anyway, it's a pretty simple lab that just shows you some of the power of sysinternals and showing you how you can pretty much see everything and anything that's going on at once on a Windows computer. So go ahead and step through this. A lot of it's just pretty much, hey, check this out. Look what it can do, right? You're going to have a few questions here, right? So go ahead and fill that out. I don't know why they don't have numbers on them, but anyway, you can just go ahead and fill in. Whenever it has a question mark here, you can go ahead and add your answer. And then there's only like 3 questions, really, 3 or 4. So pretty much these spaces, you can just go ahead and add your answer here. The Word doc, it's a quick lab. It's good to get used to the sysinternals, and it's probably good to have that on your computer anyway for troubleshooting on your own or in your personal time. Okay, let me go ahead and end this video here, and we'll talk again about the next section of the Windows operating system. See you in the next video.